This will be our last video in our chemical equations and reactions series on balancing chemical equations. So the first thing you need to remember about balancing chemical equations, because you may have seen this previously, is the law of conservation of mass, which says that mass can neither be created nor destroyed in a normal chemical reaction. This can also be related to the law of conservation of matter, which says basically the same thing. So what this means is that the total mass of the reactants and products must be equal. It also means that the total number of atoms of each element in a reaction does not change. They just rearrange into new compounds or new substances. So in order to represent a chemical reaction appropriately, it must be balanced, meaning that the total number of atoms on each side of the arrow have to match. So for example, let's say I'm doing the synthesis of aluminum oxide from aluminum and oxygen. So we have aluminum and oxygen on the reactant side, and then we have aluminum oxide on the product side. You must never, ever change a subscript once you have written it in a chemical reaction. So these little numbers never, ever change. Right? You do not manipulate these in order to balance your reaction, because that would mean you're dealing with a new substance, and that's not correct. What we will change, however, is the coefficient, the number that goes in the front of each of these compounds or molecules. And that will tell me how many relative amounts, like what's the ratio, how many molecules, how many atoms, or how many moles, and we'll get into mole concept later, are reacting. So here's my base equation, and I'm going to put some coefficients in here to make it balance. So when we go to write these, we start by listing the elements that are present on the reactants and products side, so those should match. And we're going to list how many we have in the first place. So I have 1 aluminum, 2 oxygen on my reactant side to start with, and then I have 2 aluminum and 3 oxygen to end with on the product side. Now, there's a lot of different ways you can go about doing these, but the first thing I'm going to zero in on is that I have an odd number of oxygen here, and I have an even number here and an odd number here. I need to find something they both will multiply to, because that's what the coefficients are multipliers. Well, I know that the lowest common factor of 2 and 3 is 6. So I would multiply these oxygens by 3 to equal 6, and I would multiply these by 2 to be 6. So that's how I end up with this 3 coefficient here, and this 2 coefficient here. But because this is a compound and all these things are bonded together, multiplying this compound by 2 doesn't just change my oxygens, it changes my aluminum number too, which is why I multiplied this by 2 as well to give me 4. So then my last step for balancing this would be come over here and find a multiplier to make it equal, so I can multiply 1 by 4 to be 4. So that's why I have this 4 coefficient. So this is called algebraic method. There's another method called draw-up method, which is extremely difficult to do in this video, so I will show you that in class.